Today we're going to go through how to use some of your basic electrical testers on in your standard apartment. What we have here is basically a representation of what you'd find in any condo or apartment itself. You have your inlet power coming in, you have a circuit breaker box, you have some switching and lights. You have a motor and a light that could represent either an exhaust fan in the bathroom and the light. It could be a ceiling fan in your living room or bedroom. It's still a motor and a light. Your basic doorbell, your basic door strike, GFI outlets. You really don't have anything more in your basic apartment. Okay, I mean, that's sure you have refrigerators and air conditioners, but there's still basic electricity. So this is basically a good representation of what you'll find in any apartment. So we're going to go through and show you how to use various instruments here. What this class is not is I'm not here to teach you basic electricity. That's a 6 to 8 week course that if you wanted to do it, you'd have to take it on your own or go through some internet provider type of thing. And also not here to teach you the calculus and all the equations that go with it. So let's get started on the types of testers. Your basic voltometer and or multi-tester is one of the basic instruments around. There are a couple different types, obviously, some more sophisticated than the others, but it's known as a voltometer, multimeter, goes by various names, and we'll get into some of the differences between, I won't say the quality of these, but the sophistication of the different ones. A clamp meter is a very specialized multimeter, okay? It's got the addition of a clamp. It's used for testing amperes, all right? And that's its basic function. It still has some basic functionality, but not as much as some of the more sophisticated multimeters. It's really designed for amperes, all right? And that's what the clamp is for. A solenoid voltage tester. And I'll show you a couple different testers, but the solenoid voltage tester, it'll actually buzz in your hand because there's an electric solenoid in here. And that's there for a reason, and the reasoning is that it can't be activated by induced voltage. It's important on motors. So this is the top of the line compared to this. They do the same thing, but this is a solenoid tester. Your basic non-contact voltage testers. We've got 4 different ones up here. These don't have to touch the wire in order to function, all right? They just can beep when they get near voltage, all right? Doesn't matter the model, doesn't matter the make. They're all going to do something very similar. This one has lights on strength for it. One step down from the solenoid tester would be a voltage tester that also measures continuity. What do we mean by continuity? We'll get into that into a minute. But if you're testing something and it's testing good, it's going to light up. This voltage tester just doesn't have continuity. All it can test is voltage. And this one will test voltage at different strengths, 120, 240, 480, and so on and so forth. It has multiple lights in it, but it can't test continuity.
And it doesn't work in a car?
No, this is high voltage. Now, in a car, you're obviously dealing with 12 volts. Are there versions of this that can test 12 volts? Sure. Yeah. We're not focusing on cars on this class. That's a whole nother story. All right, that would be a whole separate class in and of itself. And you have, again, now this is not a voltage tester. This, in fact, is a continuity tester. Okay, all it does is tell you if something is going to be good or bad, and it's going to light up. That's all it does. You can't test voltage with a continuity tester. Last but not least, because we really don't get into it that much, is a battery tester. Can you test a battery with a voltage tester? Only halfway. This can tell you if there's voltage, but it can't tell you if there's strength in that battery. It can't tell you the amp hour rating. Whereas a battery tester will put that battery under load as it would in some circuit, and then you can see whether it's good or bad. So for batteries, if you really want to effectively test batteries, get a battery tester. Don't depend on a voltometer, because a voltometer will only get you halfway there. And if you're talking cars, it's not something like this. Then you're talking an auto charger that'll actually be able to charge batteries and be able to tell you if that battery in fact is good or bad. We have plug-in testers. Okay, there's probably 3 or 4 different types on this. This is one of the a little more elaborate ones, but it'll test standard outlet, it'll test the GFI, and this will also test in effect if there is a solid ground or not, or if you have some ground problems. If you're out in the field and you don't have a tester on you, I put a light bulb in here and here's my tester, okay? Or if you have a lamp that plugs in, it's a tester. It'll tell you whether that circuit is live or not. Very simple. Last but not least, we get into the circuit finders themselves, or the breaker finders. This is a device that will track a signal back to your breaker. I can turn it on. Nothing's really happening while I'm holding it here. It's 2 parts, okay? Here's the sender. It just plugs in, all right? This one also has a GFI test button, as this one does. So it'll test GFIs and outlets. It'll tell you whether it's live or not, and it'll send a signal through the wires that can be picked up with this. This is for energized circuits, by the way. This tester is known as a wire tracker for non-energized circuits. We don't use it that much in basic electricity. It's more used for speaker cable, coax TV cable, and those type of cables. Computer cabling that normally is not put in conduit and can actually be tracked through the wall because it's bare wire and it's not shielded with a ground. But if you needed to use this on a non-energized circuit and you had a pair, could you use this to get back to the breaker? Yes, you could. If you wanted to get higher technology than these 2, you're probably looking in a range, then the next step up would probably be around $600 to be able to do both of them. And even at that range of price, even above $1,000, you cannot accurately track wire in conduit in your house. It's extremely difficult because your conduit is a ground and it's going everywhere. So even at that price point of around $1,000, it's still even extremely rare to be able to track conduit itself. That's it. Those are basically the kind of testers we have. Now, what do we want to test? We can test your standard outlet, whether it's in my hand or in a circuit already. We can test switches, whether it's in my hand or in circuit already. Fuses, doesn't matter the type, whether it's a cartridge fuse or a screw-in fuse, we can test those. Light sockets, with addition of some other parts, can we test the dimmer out of the circuit or in the circuit? Sure. And I'll get to some of the add-on parts that we have. This is obviously an add-on part to the circuit breaker finder, where these can now be hooked to wires instead of just plugging this module into a socket. Okay, I can hook this to wires and plug the module into that and be able to find the circuit breaker for the wires that I'm now tracking. This is actually an accessory to a clamp meter, where this is normally just put over, the clamp is normally just put around the one hot wire you're testing on the circuit. But if I had something that actually plugs in, like a big motor or whatever, that I wanted to know how many amps this thing is drawing, like maybe a humidifier or something, I could plug this into the wall, plug the unit into that, and then clamp around this, and that would give me the reading of whatever I had just plugged in, because this separates your hot and neutral wiring, where then you can get a reading with the clamp meter. All right, Brian, if you want to go over to the board, 2 ways to test an outlet. Number one, all I really have to do, if I wanted to say, is this a good outlet, and I want to test the neutral side, yeah, okay, that one's good, right? I just hooked it up to the screw, and I'm testing inside the outlet. It's a good outlet. On that side, test the hot side. It's a good outlet.
Just a quick interruption. Can you tell people what neutral means?
Sure.
My guess is somebody wants to.
On your basic lighting circuit, you're going to have 2 wires that light a light bulb or power an outlet. One is hot, it'll have your 120 volt. The other is known as a neutral, most commonly a white wire, okay, although in some circuitry it could be light gray. This is your return wire back to the breaker box. All right, you never switch the neutral. It's always one solid piece going back to the breaker box. Where this, your hot wire, can be switched. That turns it on and off.
What are you looking? What grade are you looking?
All right,
No,
a light switch. Can we actually make sure that this light switch functions properly? This just happens to be a 3-way switch, by the way, not just an on-off. All right. So we'll hook up into what is known as the common. And right now this side is on, and now it's off. So that side's working fine. Now if I go over to this side should now be on, and now it's off. So this three-way switch is functioning properly. And this is just that little continuity tester I told you about. So I just tested two devices out of the circuitry with this. Very simple. Can I also test a light bulb socket? Sure. A lot of times outside, because of corrosion, you can get a lot of light bulb sockets that'll go bad. The corrosion takes place where this rivet is, okay? And if this thing is sitting in the moisture, you know, you can get corrosion between the wire and the inside contacts. It's a very common thing on outdoor light fixtures that'll happen, and you have to replace the sockets. But, you know, again, I'm on my hot wire, all right? So that's the center contact. And is that good? Yeah. You know, you get into the neutral, and on your light sockets, that's the threading. You don't really want to reverse it, by the way, because you can get shocked as you're taking a light bulb out if the wiring's reversed. So is the threading good? Of course. So it's a good light socket. The three most common things in your house, I have now tested just with a little continuity tester. Very simple. Now, Brian, let us turn our system on. Let's get the breaker on. And if you want to use the volt ohm meter to test the outlet and the GFI.
Test the GFI first?
Yeah, sure. And we should be getting, okay, we're getting 120 volt. That's proper, right? That's our house circuit. And that. It doesn't matter. No. And if you want to try this on the same two sockets, it'll. Now you'll notice as some of this stuff already has come from the factory, this is actually a two-part system, but they've had it set up so that the pins just happen to be the same width. How about that?
Yeah, how about that?
All right, want to test the other one, Brian? You can see it lighting up, by the way, now. And a little light on the 120 volt, plus it's telling you it is working with the bigger light.
Yes. No idea.
All right.
Does that one vibrate?
No, this one does not.
Some of them vibrate.
Yeah, that is the solenoid tester that vibrates. I haven't taken it out of the box because we have the others here. But it would light up the same way, and then it's going to vibrate because of that solenoid in there. This will do the same thing that we just did, all right, except this one doesn't lock together. You have to, you know, so that's not a problem. Here is one of the old testers. If you want to test those two outlets again with the contact tester, and you'll notice one side will light up and one won't. So it's telling you which side of that outlet is actually hot and which is the neutral.
And it chirps.
It chirps. You're right.
Oh, that's fine, so you don't have to rely on visual.
Correct. Well, it'll light and chirp, and they'll all do about the same thing. Now I'm getting a constant signal. No, I'm not. So there, and it's going to light and tell you.
This side is the hot one.
Yeah. On an outlet, again, if it's wired correctly, the small prong is always your hot. The wider prong is always your neutral. Right, that's the way it should be wired. Doesn't mean it is. Okay, that's why these testers exist. Somebody may have wired these things backwards. Okay, that's why we use testers. I've been surprised any number of times by a hot neutral. Somebody used the neutral instead of the hot, and they energized a white wire. It happens to the best of us.
Does it still work?
It'll still work. It'll just be backwards. Now, the new GFIs will not work if they're wired backwards. They used to, but not anymore. Test both of those with the little plug-in. You can see, okay, you've just popped the circuit. So, pull it out. Reset. Light should be on. Test that. Green light. Just hit the, okay. This was just a standard outlet, but when he hit that test button, it shut off, okay? That's telling me that this outlet is hooked to the GFI. Okay, so we have an outlet and a GFI, but this outlet is hooked through the GFI, so when he hits the GFI test button, it's going to shut the GFI off. If this outlet was not wired through the GFI, nothing would have happened when he hit that black button. It would just do nothing. All right, now we can get a touch more sophisticated. Can we actually test, this outlet now that it's on for voltage? Sure I can. But do I need to at this point? The bulb's on. No. There's no need for me to take this bulb out of there, get my volt ohm meter and use the probes to test that outlet, because right now I know that outlet is working. So it's not worth the time to test that outlet to make sure it's working, because it is working. That's all. Now, if in fact we were testing this switch mechanism, all right, as opposed to the bulbs, to make sure that it's not, it's working properly, yes, then I can take the bulb out and see if this is giving me different voltage readings. Can I test dimmers out of a circuit? Let's say I wanted to put this in a circuit, but before I got onto the job site, I wanted to make sure it was functioning properly. Or somebody tells me in a house I've just been in that this is not working, they bring it in. Can I test this at the table here? Quite literally, yeah, I can. With addition of a couple pieces, by the way. What we've had here is basically a homemade piece, all right. And remember I said this is sort of like an add-on to the clamp meter and whatever, well, and to this, well, it basically does the same thing, This just happens to be homemade, two little pieces right off the shelf. And if I hook that into this, I've just really replicated that with a couple pieces. So yeah, can you make some of this stuff yourself? Sure. Just you have to think about it a little bit. Now this is a piece, in fact, one of the guys from Electric actually made in his spare time because of this very question. People brought stuff in and says, it doesn't work. Well, we got tired of hearing that all the time, so he created this little wire loom, all right, which I can then hook to this, plug it in, and test whether or not it works. So I'll take the adapter out. We'll just take a regular light bulb, put it on. Let's see. Hot wire. Switch wire. Come on. Ground wire. Turn power off. Okay, we'll get the switch wire back on. Make sure my fingers are clear because this is all hot, all right? I mean, these test instruments are here for a reason, but you've got to be careful using them because now when I turn that switch on, this thing in my hand becomes hot. And you don't want to be touching the screws or maybe me doing this to a ground. Well, I do that, that would hurt.
Yeah, a little tingly.
All right, so let's turn our wires back on. Oh my, it works. All right. Well, the main switch works. All right. But this dimmer does not seem to be working. So it's a defective dimmer. When the customer brought it back, in fact, it's not working. I mean, it's on, but it's obviously not working the way it should. So, at that point, you've tested the dimmer, you get another dimmer, that's all. So again, with a little ingenuity, can you test things a little more sophisticated? Sure you can. And these are all off-the-shelf parts that he put together, that's all. Put this over here. And we've used this. All right. We have tested the fuses. Again, two ways to test fuses. If this is in the circuit somewhere, okay, I don't have a fuse box here because we're using circuit breaker boxes. You can, in fact, use a voltage tester with the fuse in the circuit. If I've got the fuse out of the circuit, I can still test it because I have my little continuity tester. Okay. And it's a good fuse. It lights up. So the continuity tester and or your voltage tester, all right, set to ohms will also test that. A little more sophisticated. Okay. The voltage meter at this point, I'll set it to the lowest ohm rating, resistance rating. All right. Get my cartridge fuse back here. And basically what you can see is it's measuring 1.1 ohm, which is telling me this fuse is good. Right, there's a little resistance in it, but it's good. If it was not going to measure anything, you'd basically just be seeing that. All right, when you're good, you're going to get some sort of reading. Right now, between the two probes, I'm getting 0.9. All right, that really shouldn't be here. All right, that should be set to 0, which is an indication of the sophistication of the meter itself. Yeah. One of the things you probably won't go into unless you have some experience with electric already, you're probably not going to want to mess with your furnace and or your air conditioner, is testing capacitors. But we'll go into it just as a side because some people will know what they're doing with electric, quite a bit more sophisticated. And we can't use this meter, we have to switch meters now. We get into the more sophisticated meter, turn it on. I'm already set to capacitance. All these capacitors do have a rating to them, and what we're trying to verify with the meter is, in fact, if in fact I get a reading that sort of matches the rating on this capacitor. You want to hold that up straight. Now, this takes anywhere from 5 to 10 seconds for it to start reading. What's happening is the battery in the meter is charging up the capacitor, okay, and that takes a little while. And then I'll finally come up with some sort of reading on the meter. So it'll take maybe 7 seconds or so. Let me know when it reads. Is there a reading on it? What's it reading?
483. Oh, 483.
483?
No, 87.
Okay, so this capacitor is actually rated at 450. The meter's reading 485 or whatever, which means this capacitor is good. If I got an OL, it would mean one of two things. Either the capacitor was bad or the capacitor was over the range of the meter. So when you're measuring capacitance, you have to know the range of the meter. If my meter was only capable of reading up to 400 picofarads and this was a 450, it would just come OL with no reading, and I may assume that this is bad, but the meter couldn't read it. Okay, it couldn't induce enough voltage, where I could read this capacitor. So when you're getting into the more sophisticated tests, you have to also know the ranges of your meter.
Is the capacitator meant for 120 volts AC? Is that what makes
You can have them on 120 volt, you can have them on 240 volt, it depends on the motor. These are usually hooked to motors, whether it's the blower motor under your furnace or your compressor outside on your air conditioner. A lot of your bigger furnaces will have a capacitor hooked to the motor that's turning the fan that's blowing air through your house. All right.
that's to make it start or to make it run?
Yes and no. There's three main types of capacitors. You have a start capacitor. You have a run capacitor. This is a start capacitor, by the way. And you'll have a dual capacitor, which does both. All right. Instead of the two contacts, a dual will have 3 sets of contacts. It'll act as a start and a run capacitor. And they're usually about twice as big as this. They're usually oval, and you can tell them. All right, we have tested our outlets. We have tested our GFIs. We really haven't tested the motor circuit, now have we? So we'll turn our house back on at the breaker box.
There it goes. It's spinning.
Motor's working. So there's really no need to test it. And the lights are working, there's no need to test it. In a lot of your exhaust fans, if you take the cover off an exhaust fan, you'll see two sets of little outlets up there. The motor plugs in and the light circuit can plug in also in a lot of cases. So if you were having trouble with your exhaust fan lights, that would be the place to test, would be those little dual prong outlets that are buried in your exhaust fans. All right, Brian, let's see what we've got here. Let's find a breaker. All right, we'll just do that. It's on. And what I'll do is put this into my circuit. You can see, number one, this is telling me my circuit is actually wired properly because of the two amber lights that are lighting up, as opposed to on the other one it shows up green, okay? So some of these will read differently, but they're telling you the same thing. This one just happens to read green for proper, or this one just happens to read 2 amber for proper, and they're lighting up. So we should be able to get a reading at our breaker with that on. Is it on? We should. All right. Well, let's turn some lights on, get a little power. Obviously, it's not quite doing it. Well, it's supposed to be, and what in effect, yeah, it should be lighting up red. So what in effect you're seeing here is that some of these things tend to, for want of a better word for it, it's a work of art. As you can see, in this particular case, it is in fact not lighting up when it should be. Yes. And the metal on most of your breaker boxes is a lot thinner than this, okay? But I have seen in some cases where that will not pick up the breakers until the cover had come off. All right? So just be aware of what you just saw, that sometimes you have to take the cover off the breaker box in order to make it work. Here it just happens to be a dual setup. Now when I plug this in, it's going hot, so we also want to keep our fingers out of it. Leave that in. Now we'll just take our homemade adapter. Take that out of there. Now we're going to turn both circuit breakers back on. You can see the light is now on one of the circuit breakers. Brian, if you want to come over and then just test both breakers right here. So you can see that it's already picking up the signal. Yeah. Now, what you're noticing when he's over here, that it's way down here, he brings it over here, bring it over to the other circuit breaker. Yeah, bring it over. It starts beeping. I turn that circuit breaker off. It stops beeping. I know I've just turned off the breaker this was plugged into. Because it stopped beeping. The light's gone. Verify that, turn it back on, the light comes back on. I've just verified my circuit. So if that's the circuit I want to work on, I can now, with assurance, shut it off at the breaker box. He's just identified that in fact is the circuit and not this one with the breaker finder. All right. As I said, sometimes the cover has to come off. Not often, but because that steel is 3 times as heavy as this is, okay, it blocked the signal. So be aware that sometimes these things have a little bit of work of art. And another reason for that quote-unquote work of art is that you can, if you want to show this a little bit, all right, I'm now holding this in the wrong direction. What you want to do is put this perpendicular to the breakers, and now I get a much stronger signal at the breaker itself. All right. Now, can I get multiple readings? See, I'm getting a slight multiple reading because the breakers are next to each other. But as I move it over, obviously one becomes much stronger than the other. Now, can I get very similar readings for 2 or more breakers in a big breaker box? Yes, I can. Okay, we'll disarm this box. And then your only choice at that point is to take those multiple breakers and turn them off, and whichever one turns off the beep, you've got your circuit. And that's because of what's known as induced voltage. Now we get into why some meters cost $150 and some meters cost $30. And why this solenoid tester becomes important. Your true RMS reader, and it's in your handouts, by the way. I'm not going to go into it here. That's why I printed it out. And that's a mild explanation of true RMS, by the way. A big explanation is probably about 10 pages out of Wikipedia if you wanted to really bone up on it, but it's past the scope of this course. It really happens in motors, computer circuits, and things like that, but we mainly test motors, whether it's your motor for your HVAC system, for your air conditioner outside, or whatever, and it has to do with induced voltage. And can you get induced voltage other places also? Yes, you can. If you have a conduit with a bunch of wire in it, and one of those wires is dead, and you're testing it with a meter, and all of a sudden this dead circuit that I know is dead, I'm getting readings of maybe 50 volts or 75 volts or whatever, all right, and I shouldn't be getting that. Well, when electrons move through the wiring, they create a magnetic field, and that magnetic field is then traveling to other wires and giving a false voltage reading. All right? When you're dealing with motors, the way to test that at the lowest level is a solenoid tester. Induced voltage is just that. It's from a very weak magnetic field, but a very sophisticated meter can pick it up. And now I'm going, well, why is there 50 volts in my dead circuit? Well, the solenoid tester, that solenoid takes power to run. Induced voltage has no power. All it is a very extremely weak signal. So I use this solenoid tester and nothing drives the solenoid. There's no power behind that induced voltage. It's just a phantom voltage, all right? The solenoid tester won't be affected by it. Whereas with some meters, I can pick up that induced voltage. The circuitry is sophisticated enough to tell me I've got voltage on the line, but there's no amperage behind it.
So if I put a, the meter, let's say the meter says 70 volts, so and I put a light bulb across the two wires, it's not going to go on?
No.
Or even be dim?
No.
No.
It won't light the light bulb. It won't activate the solenoid in the solenoid tester. All right, a phantom voltage would, a phantom induced voltage will not light a light bulb.
Can it shock you?
No. But you don't know that until you test it. Because that could also be indicative of somebody that wired a circuit in series as opposed to parallel, and half the voltage is being eaten up by something else. So if there were two things on a 120 volt circuit and you're getting 60 volts, yes, that can shock you. If in fact it was a series problem and not induced voltage problem. So you still have to be careful. Again, once we test our circuit breaker, we find our breaker for our problem, and we turn off that circuit. This board is being run by one circuit, by the way. That's why I have the two circuit test there, so you can see it can differentiate breakers. Turn off our circuit and work on whatever we have to work on. How are we doing on time? All right, let's turn our ceiling fan off.
When does this blink when you hit that?
Well, we're just going to get into that actually. Now these are LEDs, all right. I have brought regular bulbs in. These are three-way, by the way. This is a three-way switch, a very old switch, as you see, by the way, with an indicator light. So when the light's on, it can tell you, this light could be out in the garage, and you want to know that it's on, so you get a little indicator light there. This just happens to be a three-way dimmer, all right. I can bring my dim down, all right. And now all of a sudden, it's going back up again. There's something wrong here somewhere, isn't there? Or I try and turn it off, and it's supposed to go off, and all of a sudden it starts going back up again. Now,
Definitely not what I want to do.
definitely not what we want to do, all right? But it does go off here with the switch, except that blink, this is an LED. What you're seeing is that capacitor just firing off in there, all right? Some will do that with some dimmers, all right? It just happens that this LED and this dimmer might not be compatible. So let's take the LED out of the circuit. Most dimmers, if they're going to be compatible with CFLs and LEDs, will say so on the package. All right, when you get to LED lighting, number one, the package must say dimmable. And when you get to dimmers, it'll usually tell you that they are LED and CFL fluorescent compatible, along with incandescent. All right, so you want to make sure that number one, this can dim, and we know it can. This is the same bulb over here. We know it can dim. Okay, this is more of a mechanical type dimmer than an electronic. But let's do that same thing with a standard bulb now, okay? And my bulb comes up. This is what's known as soft start technology, by the way. No, that's the dimmer that's doing that, okay? It's supposed to bring it up slowly, all right?
It doesn't shock the bulb
Right,
on the filament.
and I can bring it back down. And, well, right now it's not going up, is it? Okay, so there was some incompatibility with that dimmer and the LED. All right, let's try and shut it off. Still showing green. Okay. So we're off. Let's bring our up again. Now we should actually be on, and there we are, and off. So you can actually see the little light go up as the soft start. But now, I just turned it off, didn't I? Yeah. So what in fact you're seeing is there's something about this dimmer that's not working properly. All right. The way it's functioning, my switch seems to be functioning fine most of the time. All right. This dimmer is just not functioning properly. Even with a standard incandescent bulb, when I turn this switch off, it should drop down gradually instead of doing that. All right, and then just blink off. So.
Oh, so it doesn't do gradually.
Well, it's supposed to,
Yeah.
and that's where it's not in fact doing it. And now it's not turning back on. See, I shouldn't have to turn it on down here. It should turn off up. It should turn on up here also. So this dimmer is not functioning properly, even with a standard incandescent bulb, which gets hot. But you noticed it was blinking with the LED. But even with a standard incandescent bulb, it's not doing exactly what it should do. So I've got a bad dimmer in my circuit too.
Is there a way to test that with one of your testers?
Not really. Especially with the way it's not fading, you can't test that with a tester. It's just the tester wouldn't catch that electronics at all.
Put it in the circuit, see that it's not working properly, and then take the whole circuit apart again.
Yeah.
Okay.
Basically what I did there, I did that with the test loom, okay, and verified that I couldn't take that breaker and put it here because that breaker doesn't work. We tested it. It lights up, but doesn't dim down and turn off. So yeah, I could do the same thing with this dimmer here also. Now take this out of the circuit. We know it's giving a problem here. I could plug it into that circuit, okay, and test it on single pole. They'll only test the single pole, but it's definitely giving problem in a three-way circuit right now. So I would have to create a different test loom in order to, I'd have to have, another switch hooked into that circuit there in order to test the three-way. But that wraps up the class. We've basically tested just about everything in the house. We've found the circuit breakers. We've also found that some circuit breaker boxes can, in fact, block that signal. All right? It's a fact. We know that this box was heavy enough steel that it blocked the signal from the circuit tracker. So you have to be aware of that. That just because you don't get a signal down in your circuit breaker box doesn't mean it's not there. It just means it's being blocked by the ground. So there is a little art to this. You have to know your test instruments also. All right, and know what they're capable of doing, especially when you get to the higher testing like capacitors and things like that. You have to know the ranges of your meter.